Uh, Good evening, Stella. Welcome back to this video. Last time we saw basically how to integrate ax plus b to the n. So today we are basically going into how to integrate some basic trigonometric functions. We shall see how to integrate sine, cos, sec square. Sec square is the same thing as 1 plus tan square x. So remember that cosec square x, which is the same thing as 1 plus cot square x, or 1 plus 1 on tan square x. We shall see how to integrate tan, cot, and sec x tan x, cosec x, cot x, sec x, and cosec x. What I will do here is that I'll basically give you formulas. Formulas you are to remember. You need to remember, you need to be capable of recalling these formulas anytime you will be asked to. So, in certain situations like, so here I'll basically be giving you formulas. In some situations like integrals of, for example, sec square, cosec square, tan x, cot x, sec x, tan x, the proofs of these formulas, we shall see them in the next upcoming videos. You understand? We shall see them in the next upcoming videos. I I cannot show the proofs now because we are still at the beginning of integration. When we shall be introducing new laws, you shall gradually know how to prove these formulas. You understand? Donc, sans plus tarder, on va passer à la vidéo d'aujourd'hui, n'est-ce pas? Donc, the first case, we're going to see how, what's the formula if you're asked to integrate sine x. So, A, the integral of sine x dx. What is it? If you are asked to integrate sine x dx, I know that what does I differentiate to have sine x? I differentiate what? Minus cos x. So this is a better way of writing it. Je veux d'abord que tu te rappelles d'une formule que je t'ai donnée au départ. C'était sur vocabulary and it was on vocabulary and notations. There's a formula I ask you to remember. Wait, let me see. Rows. There's a formula I ask you to remember. Okay, this formula. D of f of x equals to f prime of f of x dx. I'll apply this formula in that integral. Wait, let me go back. This is it. Or is it even? Okay. I know that to have sine x, what do I have to differentiate? I have to differentiate minus cos x. So I will write the formula. Here is the formula. D of f of x is simply equals to what? F prime of x dx. So I'll replace this sine x dx by what? D of minus cos x. Because I know that if I differentiate this, if I differentiate minus cos x, I'll have what? The minus goes outside and I differentiate cos x. When I differentiate cos x, I have what? Minus sine x. So I will have minus times minus sine x. But since I was under here, there is no dy dx, and I'm differentiating with respect to x. I write what? Dx. This comes back to what? Sine x dx. That's why I'm replacing what? Sine x dx by what? D of minus cos x. I don't know if you are trying to understand me. Now, if I integrate, whenever we are integrating, let's say for example, dx, whenever you see integral of d of x is simply equals to what? X. So if I'm to integrate this, this will simply give what? Minus cos of x plus our constant of integration. Because this minus cos x is seen as a big X. So if I'm to integrate this, this will be the integral of d of big X, which is simply what? Big X plus the constant k. So the integral of sine x, we know that we differentiate what to have sine x. I differentiate minus cos x, so I write the sine x dx as what? Integral of d of minus cos x. Because if I differentiate this, I go back to this. Now the integral of d. So remember that integral of du is simply equals to u plus the constant k. So the integral of this will be what? Just what is inside, minus cos x plus k. Because this is the d of u, I just wrote u plus the constant k. So this is the same thing. Now let's go to this is a formula you should remember. So the integral of sine x is what? Minus cos x plus the constant k. Let's go to the integral, indefinite integral of cos x. Okay, integral of cos x dx. These are formulas you should remember. I wrote it here. Remember them. It's very important. This will be equals to, what do I differentiate to have cos x? That's the question I'm asking myself. I differentiate what? Sine x. So this, I can write it back as the integral of d of sine x. This will be equals to sine x plus the constant k. You understand? So let's go to the next c. We are to integrate sec square x. Okay, the integral of sec square x dx is the same thing as the integral of 1 plus tan square x dx. Okay, what do I differentiate to have sec square x? If you remember from your lectures of differentiation, when I differentiate tan x, the derivative of tan x with respect to x, I have what? Sec square x, or sec square x is the same thing as 1 plus tan square x. Remember that. So here I can write this sec square x or tan square x as the integral. What did I differentiate? Tan x. I can write it as the integral of d of what? Tan x, because I know that if I differentiate this, it comes back to what? Sec square x dx, or what? 1 plus tan square x dx. So this will simply be equals to what? So this will simply be equals to what? Tan x plus a constant of integration. So the integral of sec square x is simply what? Tan x. These are formulas you should master. Remember them. So the next one, we shall look at the integral of cosec square. We shall look at the integral of cosec square x. Cosec square x. The integral of cosec square x. Okay, let's go back. D. We have the integral of cosec. Pardon. The integral of cosec square x dx, which is the same thing as the integral. Cosec square x is the same thing as 1 plus cot square x. Oh, it's a minute. So the integral of 1 plus cot square x dx. Okay, what do I differentiate to have cosec square x? If you remember well from your differentiation, whenever you differentiate minus cot x with respect to x, when you differentiate minus cot x with respect to x, you have, when you differentiate minus cot x with respect to x, you have cosec square, you have cosec square x. So when you differentiate minus cot x, you have cosec square x. You understand? Okay, this simply means that I can replace what? I can replace cosec square x dx by what? D of what? Minus cos x. So from here, if I make d of minus cot x the subject, it simply means that d of minus cot x will be equals to what? Cosec square x dx. So this is the same thing as the integral of what? Of d of minus cot x plus d of minus cot x. So when I integrate this, I'll simply have minus cot x plus our constant of integration. So the integral of cosec square x dx is simply equals to this. Remember these formulas, very important. They are very important. So the next integral we shall see is the integral of tan x. The integral of tan x. We shall look at the integral of tan x. Okay. Integral of tan x. This is E. The integral of tan x dx. Okay. This integral, to find this integral, we are going to pass through in our upcoming videos. We shall see how to prove this type of integrals. Basically, to find this integral, you can pass through half angle identities. You understand? You pass through half angle identities. But here, as I said, we are still at the beginning. We are still at the beginning. We are not here to prove these formulas. So here I'll basically give you what the result will generally be here. So look at this. Look at this. If you look at this function, ln of ln of ln of minus ln of cos x. If you are to differentiate this, let me first recall that the derivative of ln of u is simply what? U prime on u. That's it now. So if you are to differentiate this, this would be minus. You put the minus outside. You have cos x prime on what? Cos x. This will be equals to what? Minus, this minus will not. The derivative of this is minus sine x times this. This will give sine x on the cos x, which is simply what? Tan x. So we basically see what? Qu'est-ce qu'on voit? Qu'est-ce qu'on voit? On voit que when differentiating minus ln of cos x, when we differentiate minus ln of cos x, we have what? Tan x. When we differentiate with respect to x, minus ln of cos x, we have what? Tan x. So basically, we can replace this. The integral of tan x can be replaced by what? The integral of d of minus ln of cos x minus ln of cos x. So tan x from this, tan x, if we make d of minus ln of x the subject, d of minus ln of cos x is simply equals to what? Tan x dx. So we replace this by this. So the integral of tan x is simply equals to, this is a formula you should remember, minus ln of cos x plus our constant of integration. So the next integral we shall see, let me wipe this. Let me wipe this for me to have more space. Okay, the next integral we're going to see, f, will be the integral of cot x. The integral of cot x. Okay. will be the integral of cot x. Let me see, the integral of cot x. Okay, well, the integral of cot x dx. Look at this. Look at this function, ln of sine x. If you differentiate this, you will have what? Cos x on sine x, which is simply equals to what? 1 on sine x cos x. That is 1 on tan x. That is 1 on tan x, which is equals to what? Cot x. So we see that the derivative of ln of sine x with respect to x is simply equals to what? Cot x. So from here, we can write cot x dx as what? The integral of this. If we make d of ln of sine x the subject, so this will be the integral of d of ln of what? Sine x. You understand? This will simply give ln of sine x, ln of sine x plus the constant of integration k. So the integral of cot x will always be equals to what? The ln of sine of what? The ln of sine of x plus the constant of integration k. Remember that these are important formulas you should remember. Very important formulas. We shall see on upcoming videos how to prove all of this. So ne te dérange même pas. Dans les prochaines vidéos, on va voir ça. Donc, the next integral will be sec x tan x. Sec x tan x. F g, you shall see the integral of sec x tan x. The rest dx. Okay. When you were doing integration, if you did well your integration, you can remember, I think you can remember that the derivative of sec x with respect to x is simply equals to what? Sec x tan x. Is simply equals to, if you differentiate this, you're going to see that. Recall that sec x is simply equals to 1 on cos x. Cosec x is simply equals to 1 on sine x. Okay. So, recall that, so try to differentiate this. If you are asked to differentiate sec x, it's simply, with respect to x, is simply equals to the derivative of what? 1 on cos x. How do you differentiate this? You use your quotient rule, and you will have this. You understand? So just use your quotient rule, and you will have this result, sec x tan x. So let's get to the task. We can recall that the derivative of sec x dx is simply equals to what? The derivative of sec x with respect to x is simply equals to sec x tan x. So if I'm to make dx the subject, this of sec x will be equals to what? Sec x tan x d of x. So I'll just replace this by what? D of x. So this will be the integral of d of sec x. So the integral of sec x tan x is simply equals to what? Is simply equals to sec x plus the constant of integration. Very important formula to remember. So let's move to the next one, which is the integral of cosec x cot x. The integral the integral of cosec x cot x. The integral of cosec x cot x. Okay, let's move to that. G H, the integral of cosec x tan x with respect cot x, pardon, cosec x, the integral of cosec x cot x with respect to x. Okay, firstly, if you did well your integration, I'm sure you can recall that the derivative with respect to x of cosec x is simply equals to minus is simply equals to minus cosec x cot x. So just try to differentiate this cosec x. Cosec x is the same as 1 on sine x. You use your your quotient rule and you'll be able to differentiate this and have this answer. So from here you have d of cosec x, which is simply equals to what? Minus cosec x cot x dx. So if you bring this minus, you multiply all through by minus, you have minus d of cosec x will be equals to what? Will be equals to cosec x cot x dx. So I'll just replace this cosec x cot x dx. So this by what? Minus d of cosec x. So this would be equals to the integral of minus d of cosec x, which will be equals to minus the integral of d of what? Cosec x. So the integral of cosec x cos x will simply be equals to what? Will simply be equals to minus cosec x plus constant of integration. So I'm saying remember these formulas. Remember these formulas. They are very important. Most of these formulas are found in your formula booklet, but try to remember them. It's very important, even though some of them are in your formula booklet. So the next one we're going to see is the formula for the integration of sec x and cosec x. As I said, all these complex ones we're going to see in the upcoming videos whenever I'll be in a situation where the rule, an important rule, will help you to prove these formulas. I'll always mention it, and in some situation we shall prove them. So the next one we shall see the formula of integral of sec x and the integral of cosec x. So let's go to the next slide. That was which letter even? Slide 4. That was H. Now we are on I. So the integral of what was it? Integral of sec x. The integral of sec x dx. I'll just give the formula here. I'll just give the formula. It simply equals to ln of the absolute value of sec x plus tan x plus tan x. If you differentiate this, you will see that you are going to have sec x. If you differentiate this, you will have sec x. If you are to differentiate this, you have ln of sec x plus tan x. How do you differentiate ln of u? It's simply u prime on u. So if you differentiate this well, you will have this. You will notice that the result will give you what? Sec x. So plus constant of integration. Just remember this formula for now. We're going to prove it. We're going to prove it when we shall be in a video where that will help us to prove this. So the last one is this I G G H I G. The last one is the integral of cosec x dx. This will be simply equals to ln of the absolute value of cosec x minus cot x. Cosec x minus cot x. In some cases, it's also equals to, in some it's always also equals to minus ln of tan of x on 2. It's also equals to this. You understand? So if you differentiate this, you have cosec x. If you differentiate this, you have cosec x. So try to remember these formulas. It's very, very important. It's very, very important. Try to remember these formulas. It's very important. So that was all for this video. It was a bit long. So try to go through this video and try to, if I would say, memorize these formulas for now, because they are very important. Try to memorize these formulas for now. On upcoming videos, we shall see how to prove each of these. If I would say, they are not really complex, but for now we consider them to be complex. So we shall see how to prove each of these integrals. So see you in the next video, and try to go through all what we saw. So see you in the next video. Bye.